Hi, everyone. Welcome back to Clean Tech Deep Dive. As the global energy landscape continues its rapid shift toward renewables, one thing is becoming really clear. Without reliable and scalable energy storage, this transition just won't work smoothly.
That's absolutely right.
So in this deep dive, we're focusing on something called long-duration energy storage, or LDES for short.
hmm
Think of it as, well, a whole suite of different technologies. But they're all designed to do one critical job:
Mm.
store energy, often from renewables like solar and wind for uh, really extended periods.
Yeah, we're not just talking a few hours like typical batteries.
Exactly. We mean potentially 10 hours, maybe a full day, sometimes even longer. It's about bridging those longer gaps.
Right. And when you think about how much we're leaning on solar and wind now, their variability, the fact they aren't always on, that's a fundamental challenge for keeping the grid stable.
Uh-huh.
LDES really steps in there as a key solution. It helps smooth out those ups and downs in renewable supply, making sure we have consistent power.
So it bridges the gaps when the sun's down or the wind stops blowing. Not just for a moment, but for the long haul.
Precisely, for the long haul.
Okay, so we've got this varied toolkit, these LDES technologies. Now, one of the really interesting points from an EPRI report looking at LDES use cases is that the first step isn't actually picking the technology itself.
No, it's not.
It's about understanding exactly what you need that stored energy to do. What job does it need to perform?
That's a great way to think about it. The EPRI report kind of lays out this helpful framework. It identifies key customer types, electric utilities, big data centers, microgrids, industrial plants,
Okay.
and then looks at the different energy services they might need. Things like, obviously, just providing electrical energy or ensuring enough capacity is available, improving resilience.
Right, like backup power.
Exactly. Or even grid balancing, providing reserves, and interestingly, supplying low-carbon heat for industry.
So a data center, for example, their main thing might be super reliable, constant electricity.
Uptime is everything.
Whereas maybe an island grid using lots of renewables would care more about overall capacity and balancing those fluctuating sources.
That's right. And the EPRI report really hammers this home. Once you figure out the specific set of energy services you need, you've basically defined your use case.
And that use case becomes your guide.
Exactly. Your compass for navigating all the different LDES options out there. It's not about one size fits all. It's about the right tool for the specific job.
Okay, that makes sense.
And this actually leads us nicely into a really compelling area for LDES, one that maybe doesn't get as much attention: decarbonizing industry.
Right. We focus a lot on the grid, but industry uses a massive amount of energy, often from burning fossil fuels for heat.
A huge amount. Think about making iron and steel, chemicals, cement. These processes need incredible amounts of heat, traditionally from gas or coal.
And this is where LDES comes in, specifically thermal LDES.
Yes, the LDES Council has a great report on industrial decarbonization that highlights this. Thermal LDES technologies can essentially take electrical energy, hopefully clean electrical energy, generate heat, store it, and then deliver that heat when the industrial process needs it.
So it's kind of like an electric thermal battery for a factory.
That's a good analogy, yeah. And what's really neat is that these thermal LDE systems aren't just replacing fuel. They can also provide those grid services we talked about, helping stabilize the grid, responding to signals.
So they can help integrate more renewables too.
Exactly. It's multitasking. The LDES Council report actually estimates that the LDES electric and heat technologies available today could technically cut industrial emissions by up to 65%.
65%. Wow, that's enormous.
It's a massive potential. They reckon that could tackle something like 7.7 billion tons of CO2 emissions globally.
Okay, so how is this being used now? Are there examples?
Well, the report points to a few current applications, things like firming up wind and solar power for off-grid industrial sites like mines, so they have reliable power.
Right, replacing diesel generators maybe?
Precisely. And also decarbonizing industrial processes that need heat below about 500 degrees Celsius using electrification combined with this thermal storage.
Okay, 500 degrees. The report mentions a difference between easy to electrify and hard to electrify heat.
It does, yeah. The easy category includes things like food processing, maybe some chemical production, where the temperature needs aren't quite as extreme.
And the hard ones.
That's your cement and steel. Really high temperatures, much tougher to achieve with direct electric heating currently. But LDES can play a role in both.
How so?
Well, even for grid-connected industries, like maybe a mining operation that is connected, LDES can be the key enabler to switch from fossil fuels over to relying more on intermittent renewables from the grid. It
Yeah.
gives them that buffer.
And the LDES Council report had some case studies on this.
It did, and they're pretty eye-opening. There's one about an off-grid mine in Australia. By switching to renewables paired with LDES, they could potentially slash their operating costs, get this, by 76% compared to using diesel.
76%. That's huge savings.
Massive. And achieve full decarbonization at the same time, saving about $600 per ton of CO2 avoided. Even just the mechanical LDES part contributes a lot to that saving.
So the economics, especially off-grid where you're replacing expensive diesel, can be really compelling right now.
Absolutely. And as the report notes, if you got rid of fossil fuel subsidies, the case for LDES in those off-grid spots would be even stronger.
Makes sense. What about those easy-to-electrify sectors?
Yeah, there's a case study of a chemical plant in Germany. It showed that adding thermal LDES to an electric boiler actually made the emissions reduction cheaper than just using the e-boiler by itself.
Cheaper. How's that work?
Well, the LDES allows the plant to be smarter about when it uses electricity. It can charge up the heat storage when power prices are low, maybe overnight, and then use that stored heat during peak times, avoiding higher electricity costs.
Ah, okay, so it optimizes their energy use.
Yeah. Exactly. Better demand management. And we see a similar thing in another case study, a food processing plant in California. Thermal LDES plus an e-boiler look like a really cost-effective way to decarbonize their low-temperature steam needs.
So it's not just about being green. It can actually save money, too.
In many cases, yes. Cleaner operations and potentially a healthier bottom line.
It's fascinating to see those real-world examples.
Yeah.
Now, what about the really tough nuts to crack, like cement? The report touched on that, too.
It did. It acknowledges that for sectors like cement, current LDES tech offers, let's say, more limited decarbonization options right now, mostly things like capturing and storing waste heat.
So not a full solution yet.
Not yet for the core process. But the report sees more potential in the medium term, especially for using LDES to maybe provide the very hot gases needed inside cement kilns. That requires more R&D, though.
So still work to do there, but even capturing waste heat is a start.
It's a starting point, definitely. And the report is very clear that across all these industrial applications, supportive policies are going to be absolutely critical.
What kind of policies?
Things like subsidies to help with upfront costs, long-term contracts that give investors confidence, market rules that actually reward providing clean, reliable power 24/7. These are needed to really drive it on.
Right, policy support seems key. Now, shifting gears slightly, the report also mentioned LDES for just regular grid-connected electricity needs, right, like data centers.
It did, yeah. Data centers need incredibly reliable power, 2004/7. Right now, they often rely on diesel generators for backup.
Which isn't ideal from an emissions perspective.
Not at all. LDES offers a much cleaner way. You could store cheap renewable power when it's abundant, and then use the LDES system to guarantee that constant carbon-free power supply the data center needs.
Okay, but that depends on having cheap renewables available.
Absolutely. The report points out that the feasibility for these grid-connected uses really hinges on two things: access to low-cost renewable energy, and crucially, enough transmission infrastructure to move that energy around.
Gotcha. If you have lots of cheap solar or wind, storing it with LDES for later makes a lot of sense for reliability and clean power.
Exactly.
So we've talked a lot about thermal storage, storing energy as heat, but LDES isn't just thermal, is it? The LDES Council had those four main categories: chemical, electrochemical.
Right. Mechanical and thermal. It's a broad church.
Can you give us a quick rundown?
Sure. So electrochemical includes things like flow batteries, where energy is stored in liquid chemicals.
Okay, like big liquid batteries.
Kind of, yeah. Mechanical storage uses physical forces. The classic example is pumped hydro, pumping water uphill. But there are others like compressed air storage.
Right.
Thermal, as we've discussed, stores energy as heat in materials, water, molten salts, even solid materials.
Mm-hmm.
And chemical LDES uses chemical reactions themselves to store and release energy, think hydrogen, for example, though that's a whole complex topic in itself. Each type has its pros and cons, cost, how long it can store energy for, efficiency.
So different tools for different jobs again.
Back to the use case, exactly.
It all sounds incredibly promising. But these reports also flag some significant barriers, didn't they? What's holding back LDES deployment at scale?
Yeah, there are definitely hurdles. The LDES Council and the International Solar Alliance identified several key ones. Things like inconsistent policy support governments not providing long-term certainty.
Okay, policy uncertainty.
A general lack of awareness and even clear definitions around what LDES is and what it can do. High upfront project costs are still a factor.
Always a challenge with new tech.
Investor perception, too. They might see these as higher risk projects compared to more established technologies. And importantly, existing electricity market rules often don't properly value or compensate LDES for all the services it provides, like long duration reliability.
So the market signals aren't quite right yet.
Not always, no. And then there are more practical on the ground issues.
Like what?
Things like finding suitable land, getting permits, which can take ages,
Mhm.
delays in building the necessary transmission lines, challenges getting financing, especially for smaller distributed projects,
Right.
even things like higher taxes on renewables compared to fossil fuels in some places, or long queues just to get projects connected to the grid. And sometimes, frankly, a lack of understanding among policymakers about how storage can really help integrate renewables effectively.
Wow, okay. So quite a list of challenges to overcome. It really sounds like a big coordinated effort is needed.
It does, and that's where groups like the LDES Council come in. Their whole mission is really to help accelerate the adoption of renewables and make the grid more stable by championing these LDES technologies.
They try to tackle some of those barriers.
Exactly. Through their reports, like the Roland Berger one on industry we mentioned, through providing guidance and through advocacy, they're working to create that pathway towards an energy system that's clean, but also, crucially, reliable, affordable, and secure, moving us away from fossil fuels.
And they bring together different players, tech companies, energy users.
Yeah, their membership is quite diverse, which is important. It shows there's broad agreement that LDES is vital for reaching our climate targets.
It really does seem like long-duration energy storage is, well, an absolutely essential piece of the puzzle for making this whole renewable energy transition actually work.
I completely agree. It's the critical link, providing that stored energy to ensure we have power when and where we need it, even when the sun isn't shining or the wind isn't blowing for extended periods.
Right, underpinning grid stability.
And, as we explored, enabling the decarbonization of those really energy-hungry industrial sectors, too, tackling both electricity and heat needs.
And remembering that the use case has to come first in deciding which technology fits best.
Absolutely paramount. There are challenges, no doubt policy, cost, infrastructure, but the potential LDES offers for a truly sustainable and resilient energy future is just immense.
Well, thanks for joining us for this deep dive into long-duration energy storage on Clean Tech Deep Dive. Until next time, stay curious.